notation. Yesterday we wrote down a whole bunch of different things of sequences. Today we're going to talk about series. What makes a series different than a sequence is a series is about sums. We add it up. Just like I told you about Frederick Gauss. This is the notation I'll choose to use. Use this symbol right here. You know what letter that is? Sum. It stands for sum. It is the letter sigma. In the Greek language, it is a capital S. In ancient Greek language, there were no capital letters. Later on, this became the capital letter S. Lowercase would be this. If it's in the middle of the sentence, put that. If it's at the end, this is the uppercase. If any of you ever work with Microsoft Excel, you'll see this as you use sum. This tells you the beginning term. This tells you the end term. This tells you the rule. So, for example, instead of writing everything in, let's say you got 100 terms, it'll take a while to write it all out. So they express this summation notation. So we begin with I equals 1. And I just means the term number. And that's what we plug in. You plug it in for n. You could also say 3i plus 1. So anyway, so if we plug in 2, we get what? 7. And then summation means add. The next number you plug in is, after 2 you plug in 3, and you would get 10. After 3 you would plug in 4, you would get 13. And after 4 you would plug in 5, and you would get 16. And that would be it. So this is the summation notation form of that series. You do the next one on your own. So 5 means we end with the 5th term. So 3 times 5 is 15 plus 1 is 16. So now we're done. That's where we end. Yes, it is 4. 2, 3, 4, 5. 4 terms. You stop when you get to whatever term that is. Go ahead and do B. Plus 8 plus 32, correct? 8C, you would plug in 1, and you would get negative 3. Plug in 2, and you get negative 8. Plug in 4, so 3, you get negative 13. 2 minus 15 will be negative 13. And then we don't want to write everything to 100, so we go plus, dot, 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 plus, and then that'll show the last term, which would be 2 minus 500, 4, negative 4. So if you have what you feel is too many terms to list, go ahead and place a dot, 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 dot. Have to have at least 3. More than 9 dots would probably be needed. Okay, you do the next one. And you don't have to actually express to spell it as a number. You can just leave it as one form. People understand what you're doing. You can see that the negative 1 to the 10 oscillate back and forth between positives and negatives. All right, so let's suppose that we want to add things like this up. We're going to start with the arithmetic series. The partial sum of the arithmetic series is as follows. The sum of n terms is equal to, take the first term plus the last term, just like Mr. Frederick did. But then you have half as many combinations as you have terms. So to show that, divide by 2 times the number of terms. That's a rule that it shows explicitly what we did on the board earlier. So we will start with this summation here. If you were to plug in 1, you would get 4. Plug in 2, get 7, so on and so forth. Okay? So we want to add that up all the way to the 20th term. Plug in 20, you would get 61. Well, it says that the sum of the first 20 terms is equal to the number of terms, which is 20, times the first term. What is the first term? The last term divided by 2. I like to take the 20 and divide it by 2 to get 10 times 65. 650 is my answer. Did that quite quickly, didn't we? Isn't that a nice trick? Why don't you try the next one? Okay, 1020. So 15 times 4 will give me 60. There's 160. Flip it over. What makes this different? 1020. Yes. So we have a question that they're not asking. You have the 96 plus 40. Divide by 2. So my guess is that what you're typing in your calculator is this. You're doing 15 times 96 plus 40 divided by 2. And instead of taking the 96 plus 40 divided by 2, it's just taking 40 divided by 2. So that is what you did. 96 plus 40 divided by 2. So again, you were just dividing the 40 by 2. You need to divide the whole thing by 2. So you'd have to be parentheses. Alright, we flip over. Here we don't know the number of terms. The sum of n terms is equal to, well, you take n times the first term, the last term, you divide by 2. Just gotta figure out n. We got a good idea? So this would give us 50 over 2 is 25, 25n, but we still need n. Remember this from yesterday? We just need to know which term 58 is, right? So 58 is equal to negative 8 plus minus 1 times the difference. What's the difference? 3. Or 66 is equal to 3 times minus 1. The 22 is equal to 3 minus 1. What is n? N is 23. Therefore, I have the sum of 23 terms equal to 23 times. We said that this was 25. I think that did that correctly. 25 times 25 is 625. So try an extra line. There we go. What is 49 times 891? Wait, how did I get 49? N is 98. Divided by 2 is 40. I feel like I'm less likely to make mistakes when I reduce from the point. Yes. It is multiplying because there's no anytime you don't have an operation sign between numbers and something else. Just subtracting 9, 9 divided by 9. So 873 divided by 9 gives because the difference. So in the formula, base of n is equal to base of 1. The difference between each term is 9. It's always the latter minus the former. Okay, so suppose it's a geometric series and not a arithmetic series. Then the sum is equal to base of 1, the first term, times 1 minus r to the n over 1 minus r. Question? Okay, R, we have a geometric series, as you see here, sum of n terms is equal to a sub 1 times 1 minus r to the n of 1 minus r. So I will expand this so we can begin to see what it looks like, but we have the sum of the first 9 terms. What is the first term? If I plug in 1, what do you get? 1. Let's plug in 2. If you plug in 2, what do you get? Plug in 3, what do you get? 4, right? And if you were to plug in 9, you get 1 half to the 8th power, which is 1 over 256. So if we use our sum formula, the sum for the first 9 terms is equal to a sub 1, which is 1, times 1 minus, what is your r value? What is my ratio for my multiplying by every time? Yeah, it's that thing you're taking to the power. 1 half to the, what is n? 9 divided by 1 minus, what is my ratio? What is 1 minus a half? A half. Instead of dividing by a half, I could multiply by 2. So I have 2 times 1 minus 1 half to the 9th power. So let's do that on our calculator. Which part? Okay. So if I turn my calculator on, it's 2 parentheses 1 minus parentheses 1 divided by 2 to the 9th power. You see I get 1.996. If you actually wanted to work it out, you could say 2 times 1 minus 1 over 2 to the 9th is 1 over 512. So we get 2 times 511 to 512, which is 1022. 511, which is what we should have. So, let's try another one together. B. Sum of the first 6 terms is equal to, what is your first term going to be? 6. If you plug in 1, you get 1 minus 1 is 0. Anything to the 0 is 1. Times 6 is 6. Times 1 minus, what is r? 2/3 to the nth power, which is 6, divided by 1 minus 2/3. What is 1 minus 2/3? 1/3. Dividing by a third is the same as multiplying by. So we have 18 times 1 minus 2/3 to the 6th power. 3 to the 6th is kind of out of my range. I stopped doing things at that point. 18 parentheses 1 minus 2 divided by 3 to the 6th power. I get 16.42. What makes the next one more difficult? Yeah, you don't have the last term. So it's the sum of n terms is equal to, what is the first term? 10 times 1 minus, what is r? 1 half, multiplied by a half every time. 1 half to what power? We don't know, so it's n, divided by 1 minus 1 half. What is 1 minus a half? A half. And dividing by a half is the same as multiplying by 2. So I get 20 times 1 minus a half to the nth power. Only I could figure out n. Thing we did yesterday. Remember, for a geometric series, the nth term is a sub 1 times r to the n minus 1. So what is the last term that we're trying to identify? 5 over 32 is equal to, what's the first term? 10 times, what's the ratio? To the n minus 1. How would you start by solving that equation? Divide by 10, 5 over 320. I won't even reduce it, we'll just leave it. How do I get rid of a base of 1 half? Log base 1 half. If I take the log base 1 half of both sides, what happens here? N minus 1 equals. How do I type that in my calculator? Take the log of what? Doesn't matter. Take the log of 5 over 320. Divided by the log of 1 half. 6. So n is 7. So we have 20 times 1 minus a half to the 7th power. So 6 is n minus 1, so n is 7. That's a little trickier example, huh? I promise I'm not going to put something like that on a test, but I knew that if I didn't show you it, you'd want to see it. So why don't you try the next one on your own? You can do it, folks. I believe in you. Stop. Okay, so the very last type of example. Do you think it would be more difficult to find the sum of a finite set of numbers or an infinite set of numbers? It would seem infinite. You do not have to duplicate this, but please watch this so you understand what we're doing. If I take the geometric sequence, what is that first term? If I plug in 1, what do you get? If I plug in 1 for n, what is 1 minus 1? 0 times r to the 0 is 1 times a sub 1 is, and then your next term will also give you a sub 1. But a sub 1 times r, because it will be r to the first power, right? And your next term will be a sub 1 times r squared, a sub 1 times r to the third, dot, 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 right? And that would be a sum of a infinite geometric series. Watch. What do all the terms have in common? A sub 1. So you might want to factor that out. But we're going to factor something else out. We're going to factor out an r. Now, you may not like that because you say this doesn't have an r, so I won't factor it out of the first one. But watch what I get. This is where the aha moment needs to happen. If I factor the r, I get a sub 1 times r then. A sub 1 times r squared. And if I did it again, I would get what? Does this look familiar right here? What does this look like? Right above it, right? Which is the same thing as s, the sum. This is the sum. So I can take all of this and replace it with s. Well, I'll just gather that on over to the other side here. I want to solve for s. I'll factor it out. And in order to solve for s, I'll simply divide. So an infinite series is actually really quite simple to find the sum. Our formula is as simple as it gets. Allow you to see how this works. We're summing this time from 1 to the infinite term number. You're adding up an infinite set of numbers at this point. You've never done this before. I plug in 1. What do you get? A half. Oh, I'm sorry. Anything to the 0 power is 1. Thank you, yes. Plus, now I plug in 2, and you get a half. You plug in 3, and you'll get 4. So you're adding up that set. There's an easy way to do it. We say that the sum is equal to a sub 1. What is the first term? 1 divided by 1 minus, what is r? Half. That's 1 minus a half. What's 1 divided by a half? Come on, that's cool. So exactly. So when we did the doorway thing yesterday, we added up that sum, right? This time we just attached a 1 onto it. What's the first term here? 6. What's R? 2/3. What's 1 minus 2/3? Yep. Raylan first asked the question, and I didn't know how serious the question was. Now I've heard it twice. So after we show you next two, can I then tell you? Exactly. There's a lot of people that won't. And I'll bring that back to you in a little bit. Okay. What is the first term? What's R? 1/3. The rule of 18. What's first term? What's R? Nobody says boo about that problem. You guys, no. You guys, you're saying that 3 plus 6 plus 12 is going to have to -3? No. The formula only works if the absolute value of R is less than 1. If you were to add up these numbers, they go to infinity. That's absurd. That doesn't work. When your R value is greater than 1, it doesn't work. There's your assignment. It's online as well. Check it there.